I'm going to introduce, as I said, the speaker, who is John Stack. John is Director of Digital at the Science Museum Group, and he's also Principal Investigator of the Heritage Connector Project. His presentation today will focus on machine learning and cultural heritage. What is it good enough for? So over to you, John.
Great, thanks very much, Maria, and thanks to the conveners of today's session for inviting me to talk. So I will now try and share my screen. Hopefully you can see that. Okay, so title of my talk today is Machine Learning and Cultural Heritage. What is it good enough for? So, like a lot of cultural institutions, we're undertaking a very large-scale digitization project, and we're publishing thousands of new objects online each month. And those are being published into a web interface, which is in many ways very similar to lots of other web interfaces in the libraries, archives, museum sectors. And so it's primarily driven by keyword search. The digitization program is rapid, and it therefore focuses on breadth over depth. So the majority of the records that we publish online are actually quite thin. This is sort of fairly typical. We might just have another couple of sentences somewhere describing the object. And so we have relatively thin records and a keyword search, and that's very common. So here's the V&A's recently relaunched collection. And as you can see, it looks very, very similar to ours and takes broadly the same approach in terms of search and discovery. So we're undertaking with the V&A and with the School of Advanced Study at the University of London and funded by the AEHRCs towards a national collection programme, a project called Heritage Connector, which has the subtitle Transforming Text into Data to Extract Meaning and Make Connections. So here's the primary research question. How can existing tools and methods be used to build relationships at scale between poorly and inconsistently catalogued digitized collection objects and other content sources? So at the moment, this is what our collection looks like. Thin records, which tend to have relatively small number of links to one or two other things or people or whatever in our collection. And what we're looking to build is connections between our collection to Wikidata, which is the linked open data set that sits underneath Wikipedia, and I'll come back and talk a little bit more about that a little bit later. And then through Wikidata, we can then link on to other things, and we can also build more links between the things in our collection, the things in the V&A's collection. And then we can also undertake once we have those things, we can start to create kind of clusterings. And there are some categorizations within our collection, but they tend to be quite rigid and quite difficult to change, and they tend not to address some of the things that the public and scholars and others, audience members are interested in. So there's three kind of areas that we're exploring in terms of outputs. One is improving collection interfaces, primarily online, I think we're talking about there, improving discovery and improving links to other sources. And we're using three sets of technologies to explore that. One is artificial intelligence, primarily machine learning. One is linked data, and the other is knowledge graphs. So our data sources, are these. So we're using the Science Museum Group's collection catalogue, the V&A's collection catalogue, Wikidata, the Science Museum Journal, which is our peer-reviewed kind of scholarly online publication, and also the museum's blogs, which are a kind of more informal kind of content, but much of which is related to the collection. So we'll quickly whiz through each of these groupings of three things, and we'll start on the right-hand side. So in these three technologies, I'll start with the second two. So why and what it is linked data. So collection catalogues at the Science Museum Group, but in general, because of the way that collection management systems work, are kind of groupings of tables. And so the data structure tends to use interlinked tables in a relational database to drive collection interfaces, research, discovery, and so on. What knowledge graphs do is they use kind of series of statements, which has a kind of form, predicate, a subject, and then a kind of connector between them. So here, this person founded this company which made these things. And what can knowledge graphs do well? They can handle very complex relationships. They can hold different kinds of data relationships than we might traditionally hold in our collection management system. They can calculate relationships between things very quickly, and so sort of closeness between interrelated things is relatively easy to construct and calculate. And they can bridge across disparate content and merge data sets together and infer new relationships. And they're also highly flexible and can change and grow easily. And then lastly, and critically for this project, they're machine readable because they end up being written as a series of links or statements, as you see at the bottom there. So what are the artificial intelligence tools and approaches that we're using to generate this knowledge graph? So fundamentally, we're using machine learning, and there's three parts to it. The first is is the kind of easy wins. So within our collection catalog, there are existing identifiers and URLs and links. And so we can extract those, and they may be added into the public text, or they may, and in fact more likely, be added into notes fields within our collection management system by curators at different points in time. So the overall structure of the heritage connector is an ingestion of the tabular data from the collection on the left-hand side using these three approaches in the dotted box, and then using a number of techniques to link those things then on to Wikidata. So why Wikidata? So underlying Wikipedia is a whole set of facts, and so they're normally presented, or they're most obviously presented in the box in the right-hand side there, where you can see there are sort of statements of founders and industries and so on, and other identifiers, and sometimes you see them at the bottom of the page as well. So this is a particularly rich record, and then those things are constructed in an open data set which we can access programmatically. And one of the reasons why we're interested in Wikipedia, apart from the fact that it's open and we can get at it to experiment with, is that it covers an enormously broad range of subject areas, as does our collection. So we can kind of range across the collection and start to infer links into other places and other things. And then the data is structured in as linked open data, as you can see here. So in terms of like processing these easy wins, we grab all the URLs, we resolve them into links. We can use Sparkle to query Wikidata to pull back the identifiers of there. And even if the external link in our database is not to Wikidata, it might reference some other identifier which is in Wikidata, and then we can pull those IDs back and put them into our knowledge graph. So the second area is around disambiguation. So that is looking at people, companies, objects, organizations, and so on that are within our collection catalog, and seeing if we can draw a connection from there to Wikidata or to some other data source. So kind of broadly speaking, what this tool does is it's learning to distinguish whether one of our records and a Wikidata record is the same thing. So here we're using a classical machine learning method, as it requires less data and less computational power. And so here's an example of links that were built with a disambiguator. And so throughout this process, we're not purely interested in perfect connections. We're interested in how we might build a larger number of potentially imperfect links and present those to see what kinds of use those can be put to. So in particular, you can see that these ones here are actually pretty good. So what is this method good at? It's particularly good at people, and it's pretty good at organizations and companies and so on. It's much less good on individual collection objects, because they tend not to have records in Wikidata and other places unless they're products, and most of the things in our collection tend to be unique things which aren't which don't have records. So there you can see it's 1/4% of the objects having a record. So then the third area that we've been exploring is using named entity recognition on the catalog text. So where there are descriptive texts, we can use natural language processing to find the words or entities in that piece of text of a kind of set of predetermined types. And it does this by learning what these look like and where they tend to appear in sentences. So here's some examples. It's pulled out. So it's pulled out both links to within our own collection, but also to other related entities in Wikidata. So here we mention the Soyuz 11 and the company that made it. Those things don't exist in our own data set, but once we have those, we can then kind of bounce through them to pull back other information. In terms of making this named entity recognition, kind of improving it, we've done some kind of tweaking to train the model on the ways in which curators and others and catalogers have written about the collection. So in this case, how do dates typically get presented in our collection, and also to train the collection that there are some things that are called the something collection or the something archive, and so that it identifies those as things rather than just people's names or names of companies and so on. We've also used the collection itself as a dictionary, so you going through the collection and starting to pull out things that we know are companies or particular kind of aspects of the collection, and fed those back in to train the model further. And then we're using a kind of custom-built entity linker and something called Blink, which is from Facebook Research, to link these entities to within our own collection and to Wikidata. And so this is the result of that piece. So the second row is things that are linked within our own collection, things that are unlinked, which means that there's no link in our collection, but there's no link in Wikidata, but we know it's a thing, or the system thinks it's a thing, and those things that are linked to a relevant Wikidata page. And what you can see is we've now generated 750,000 links. And we pulled in from those links about 100,000 Wikidata pages into our knowledge graph. And part of the reason we're pulling these things in is that we want to be able to explore those things at speed, and connecting to Wikidata, especially for complex queries, can be quite slow. So we're pulling in and essentially caching those data sets within our own knowledge graph, because that was a much faster thing to connect to, and means we can start to experiment with the kinds of things that we'll talk about a little bit next. So this is the area that we're working on currently. We're looking at collection interfaces, improving discovery, and providing links to other sources. So what we have currently is essentially a Sparkle endpoint onto our knowledge graph, onto which we can run different kinds of queries across the entire data set. And then we can start to visualize those as force-directed graphs, so we can start to see the relationships between people and things. And then we can start to make different kinds of queries that we wouldn't be able to make within our own collection. So this is a relatively simple one that looks at people in our collection and then transverses through Wikidata to identify where those people are also who have references or identifiers in other collections around the world. So we can start to build links between our collection and others' collections that users could kind of transverse between collections. And then we can start to ask kind of more complicated and kind of nuanced questions. So what this query does is it takes texts related to men and goes through and finds women who are mentioned in the text. And so what you can see is there, you can see that some are clearly married to other people. Somewhere in there, we discovered this morning, is Lady Gaga, so we're very happy about that. But it's a way that we can start to explore the collection in new ways and start to look at kind of areas of kind of bias and absence within the collection. So husband and wife teams working on scientific discoveries is a very typical example of where a kind of gender bias within the collection would be manifest, with the man being largely credited or being the kind of primary record for that work. So the things we're working on next are to kind of take this interface, which is quite complex to work with and is not for the general public. And we're working on knowledge graph embeddings, which is a way of starting to cluster and map out the knowledge graph to start to be able to create interfaces on top of it. So this is a very small section of an enormously large data set, but you can start to see it's pulled together some things and started to cluster them together. But our hope is to do this at enormous scale and to build something that will transverse the entire data set, and you'll be able to sort of click into it and explore it. And in that way, it's not really proposed as a kind of public user interface, but it's a way for us to start to explore the collection and the resulting machine generated knowledge graph in a way that we can start to work out what kinds of things would it be useful to build interfaces on top of, what kinds of absence and clustering and so on emerge. And then we'll start to build widgets that we'll publish into our online collection using that data set. So that's something we're going to be working on through the summer. So going back to the original question, machine learning and cultural heritage, what actually is it good enough for? So based on where we are now, which is about 2/3 of the way through our project, we think it's great for suggesting possibilities and highlighting connections between things. We think it's actually pretty good at identifying trends and gaps. It's good at visualizing kind of range and diversities of collections, which is something that it's really hard to get out of a keyword search box. So a person coming to a collection and faced with a search box, is quite hard to work out the kinds of content that they might find in a collection, especially one that's diverse as ours. We think it's pretty good at identifying related content, which is why we're looking at blogs and scholarly articles to start to see whether those blogs and articles will kind of cluster close to related objects, even if they're not things that directly mentioned in the text themselves. Articles on sort of thematic areas may move close to related content. Obviously, it's brilliant at working at scale. And it's very good at bringing kind of new terminology into the collection alongside the traditional cataloguing approaches. So what is it less good at? Excuse me. It's becoming increasingly clear that the content that's generated by the machine learning methods need framing and contextualization, because there are false positives in there and they're not always apparent, and they may require specialist skills or knowledge to kind of understand that they are false positives. And that really starts to challenge the way that cultural heritage institutions and their notion of their collection catalogue, which is normally treated as a kind of canonical record. So putting machine learning next to it, which has all these advantages around suggesting new directions and new areas of discovery and exploration, it needs to be, the outputs need to be kind of presented in a way that the user understands that this isn't necessarily canonical in the same way that they might traditionally have understood it. We think it's really important to understand what it can't do yet, and so there are strengths and weaknesses to the different methods used, and so we're trying to explore what those are. And then, so fundamentally, it's important to approach machine learning in cultural heritage collections kind of critically, so we can understand the context, and that ultimately these things are models applied to the content, in the same way that a weather forecast is a model of the weather. It's not actually the weather. Thanks very much. That's it for me. And these are the links to the various GitHub repositories where there's open source code, there's a blog, and there's a first paper published. So I'll pop those in the chat in 1 second. Thanks very much.